that?
Yep.
Okay, so now we go back to this inequality. So since it's less than or equal to, that means it's a solid line. So less than or equal to, greater than or equal to, those are solid lines. If it's less than or greater than, those are dashed. Okay. So you want to put some arrows on the end. Now to decide which side to shade, do you remember anything from your notes about how to decide that?
Whether it's negative.
Okay, there's two approaches, and the first approach is when it's actually solved for y. When it's solved for y, when you have a y less than or equal to, you're always shading below.
Okay.
If you have a y greater than or equal to, you're shading above.
Okay.
So when you look at this line down here, we're going to shade below it. So below it is everything to the left of it, which is below in this case. Any questions on that or anything?
No, I don't think so.
Okay. So we get to try another one here. And it says the inequality 2x plus 5 is less than y. Okay. And there's a couple things going on here. One is that we really want y on the left. So see how I think sometimes they call this the mouth of the inequality. The mouth has to be pointing towards the y in this case, because the y is it's opening up there, and then you move this to the other side, but you have to get that inequality in the right place.
Okay.
It's kind of like this. X less than 1 is the same as 1 greater than x. Do you see how now this time the pointy end is going towards the variable?
Yes.
So whatever it is, it still has to be that way, but you want the variable on the left side.
Okay.
Okay, now in terms of graphing this, y equals mx plus b. M is what and b is what in this problem?
M is 2 and B is 5.
Yes, very good. Which do you use to graph first, the m or the b value?
The B value.
The b value, good. So we go up to 5. 1, 2, 3, 4, 5. And then the slope of 2 is really 2 over 1. How much do you go up or down? And then how much do you go to the right based on the slope?
So you go up 2 and right 1.
Up 2 and right 1. And then if I just go backwards, I'll add a point there. And if you're doing this on your own, it's not important that you get it exactly right or on the grid. The direction's more important here. Now, see how this is a greater than? That's a dashed line. Okay, dashed line. And then because it's greater than, do you shade above or below it?
You shade above.
Above. A greater than or equal to, you shade above. Okay, so we've done a couple problems here. I think it'd be good for us to do a couple more here. Let's say it's y greater than x minus 4. Okay, can you tell me the slope and the b value from this, please?
The slope is -4 and the B value is 1.
You've got those flipped.
Oh, okay.
Slope is 1, b value is -4. And which do you start with first?
The -4.
-4. Now, what does this slope of 1 mean? Like, how do I turn that into like a direction?
Make it a. I forgot what it's called, but you put a 1 on top of 1.
Good. You make it a fraction and you put a 1 on the bottom. Yeah. So how much up or down are you going?
You're going up 1, right 1.
Up 1, right 1, up 1, right 1, and so on. Good. Now, is it a solid or a dashed line, and why?
It's a dash because there's no line underneath it.
Exactly right. Okay. And then do you shade above or below it?
Above.
Good. Okay. So here, I'd like you to try doing one on your own here. Do you have any questions on this? I know I'm scrolling a little bit fast, but I can slow down here if you want to write anything down, but I'd like you to
No.
try one on your own.
Okay.
Okay. So what I want you to do is try graphing the following: y less than or equal to -2x plus 4. So I want you to graph. I can't see your graph, so I am going to graph it here, but I'd like you to spend a minute or two and see if you can figure this out on your own, please.
Okay. Okay, Matt, I have it.
Excellent. Okay, so I'm going to work through it just in case you want to look back at this notes. The slope is -2. You write that as -2/1. That's 2 down and 1 to the right. Your b value is 4. You start at 4 and you go down 2 and right 1, down 2 and right 1. It's a solid line because of the less than or equal to solid line. And then you shade underneath. Any questions on that?
No.
Does yours match what I have?
Yes.
Roughly. Okay, awesome. That's great. All right, excuse me here. So let's look at another question here. What do you feel like about the pace of this class? Would you say it's just right, too fast, or too slow?
I think it's fine.
Okay. All right, so Corliss earns an hourly wage as well as tips. Are you working yet?
No.
No. Okay. So a lot of service jobs, you get tip money, and everyone loves that. So that's what's going on here. But he also gets like a guaranteed amount each time he works. So and that's what they're trying to show you here. They're trying to show you, hey, H is your hours worked. He gets $11 an hour, but he also gets $35 each day. All right. So what they're trying, what they want you to do in the answer space is they want you to convert this into words. And you might think, well, it's M greater than 11 times H plus 35, but they don't want that. They want it in the context of the problem. So they want you to say M. What is M in this problem?
M is income.
Income. So they want you to say Corliss is, yes, I guess it's just that, income is greater than. Okay, so I got that from the letter M and that symbol. Corliss income is greater than. Okay, And then this is where you have to use the units from the problem. So you have to say things like $11 per hour, because that's what H represents. $11 per hour plus $35 in tips. Okay, so let's try a different example, something that'll make more sense to you, Jeremiah. So Jeremiah's, you go and work out, you do some exercise stuff. You're gonna burn at least, and let's go like this. Let's go 400 calories per hour that you work out, plus your body already burns 200 calories. Okay, so in this problem I'm laying out for you, I would want you to say something like Jeremiah burns at least 400 calories per hour, as well as 200 baseline calories just from moving up, just from your normal stuff.
Okay.
So you have to be able to convert these into some of these inequalities into words. So now I want to give you kind of a shortcut to this. So the symbol, this symbol right here, it means less than, but it sometimes means at most. Greater than, let me get back down, less than or equal to, I'm sorry. We'll say, we've already got there. So the greater than or equal to, sometimes we say at least. And then less than or equal to. So sometimes there's some other words here, but that's what we're trying to get to in some of these problems here. So let's look at another one and see if we can come up with the correct answer. All right. Looking at these. So some of these are hard to come up with on the fly. I'm trying to find some problems we could do together, but all right. So a library has at least, so you might think, oh, well, that's greater than or equal to 900 square feet to create a new study area. So each study cubicle uses 6 square feet, and each computer station uses 8 square feet. So they want you to use S is the study cubicles and C is the number of computer stations. Okay, so it's 6 goes with the S and 8 goes with the C. Okay, but they only have, and I actually don't like the way this word, they only have 900 square feet. So can these two add up to more than 900, or does it have to be less than 900?
It's less than 900.
It's less than or equal to 900. So sometimes so this is one example. Maybe you want to go out with some friends and you got $20 to spend, and you can buy sodas cost $1.50 and a slice of pizza is $2, and you can only spend up to $20. Maybe you've had that scenario happen in the past. So budget problems are almost always these less than or equal to, or when you have space problems, area problems, they're almost always less than or equal to. Okay, let's try another one here. All right, so it says Lakita is going to plant trees and bushes. So they use the letter T for trees and B for bushes in her new yard. Her budget cannot exceed $150. She cannot exceed her budget of $150. Each tree costs $45 and each bush costs $20. Okay, so what is the number that goes with T?
20.
45.
Oh, I got mixed up.
45T. And what is the number that goes with B?
20.
20B. And it's a budget problem. We already said that budget problems are generally less than or equal to something like that. So that should be enough to actually retake your, what was it called? It's called a checkpoint. But what, in the meantime, let's go back to doing some more inequalities. Actually, this is another word problem, so we'll look at this. Okay, Lydia needs to buy both lanterns and streamers. That's an interesting combination. Lanterns and streamers for a party, and she has a maximum budget of $15 for these decorations. So each lantern costs $7, and each pack of streamers costs $5. And they want you to graph the solution. They tell you that X is the number of lanterns and Y is the number of streamers. So see if you can write the budget equation for me, please. It is an inequality and it will involve the 15, the X, the Y, the 7, and the 5. So go ahead and try writing that out for me, please.
I think we got it.
Okay, so the what I wrote down is 7X plus 5Y has to be less than or equal to 15. Is that what you wrote down?
Yes.
All right, excellent. Okay, so I went ahead and graphed this for us. Let me show it here. Actually, I don't like that. There we go. That'll be better. Okay. Okay, so here's the graph of this problem here. And the X is the X represents the lanterns and Y represents the streamers. Now, if you read the language in the problem, are you allowed to buy part of a pack?
Yes.
Okay, so when you go to the store, you buy some cereal, right? Are you allowed to cut open that other box and like get half of another half bag of cereal?
No.
No. So that's what they're asking you here. So they're implying that there's only what are called whole number solutions. So for example, you could buy 0 lanterns, but 3 streamers. Do you see that?
Yes.
You could buy 0 lanterns and 2 streamers, but why would you do that? Because you could get one more. Do you see that?
Yep.
You could buy 1 of each. You could also buy 2 lanterns and 0 streamers. And that's because this is a real problem. It's one where you have to decide. It's kind of like whole number solutions. So you can't cut things in half. It's not like that slice of pizza where you try to keep cutting it in half, and so on. Any questions on that?
Nope.
Okay, so let me new share. We're gonna do something slightly different tonight here. So here's what I'm doing, Jeremiah. I'm just going right to your assignments, and I'm looking at whatever you've got to do for that. And if you want, what we can do for future lessons is like we can work on some of these together. Like for example, on the 29th, you're going to have a workbook thing due. We could work on that together.
Okay.
The exam, if you want to pull up some exam questions, we can work on that together. My point is like, I want to help you with this stuff. So don't feel like you got to rush through it. You could do a submission and then we could work on it together, and then you can go back and try it out. But you actually know enough now to do both workbook 14.3 and checkpoint 14 if you get another attempt.
Okay.
All right. Well, I think that's it for tonight. I will send you the notes here shortly, and I'll see you in 2 days.
Okay.
All right. Thanks so
Bye.
much. See you. Bye.